Hello everybody, we're group 37 and our project name is Ucf Go. UCF has a total of 7 parking garages for students and employees, each holding from about 1,000 to 2,000 vehicles daily. Finding a parking spot during rush hour can be very complicated, but what's more complicated is remembering where you parked your vehicle after having to pack up your things and rush to class. Students sometimes come and go from campus multiple times a day, and remembering which garage you parked, on what level, and on what side can be very disturbing. The birth of our idea came from this problem. Our idea derived from a shopping mall business model where the user scans a QR code with his or her phone and the location is saved on the user's phone. We would like to take that idea to the next step so that the user won't even have to scan the code by hand. Like the shopping mall idea, we would like to save the user's vehicle's location and show it on a map after he or she has parked. Our mobile app would connect to each individual parking spot through a QR code and that once scanned by our hardware, it would transmit the data with the user's location. The web application and the database would be on our web server. The user would use an Android application. The user's automobile would have a microcontroller that has a camera and a power system and that is connected to the user's phone via Bluetooth. And each parking spot would have a QR code that would be scanned by a PIR sensor from our custom PCB that has a Wi-Fi module and also a power system. These are some of the specifications and requirements, but we're going to focus on 3 of them. The PCB shall scan and return updates at periodic time intervals. The mobile app shall report any changes to available spots at a specified time after an event trigger. And the microcontroller should be able to scan a QR code with up to X amount of the code obscured.
In order to connect our PCB to the mobile app, we used a variety of services. It all starts with the HC-SR501 PIR sensor, which takes data of its surroundings and can detect motion at the parking spot. It then sends this information to the ESP8266 Wi-Fi module, which is flashed with firmware from the Arduino IDE to connect to the popular web service, If This Then That. If This Then That allows the user to program responses to an event. If This Then That is then able to communicate with the Mongo database and show the updated occupancy state there. In the upper left, you can see my If This Then That applet. The trigger is the PCB sending a web request when it receives a signal from the PIR sensor. Then it updates a cell in a Google Sheet with the timestamp that the trigger occurred at. Using Google Apps script and a few clever scripts, I was able to program the sheet to change the occupancy state with each trigger and then send that information over to the Mongo database. Here is a brief overview of our PCB. The main component is the ESP8266 Wi-Fi module. We also have the HC-SR501 PIR sensor with 2 potentiometers on it to control sensitivity and time delay. If I turn the PCB on, it'll fairly quickly connect to my home network as programmed in the Arduino IDE. Once it connects to my home network, it'll pretty quickly start taking data from the PIR sensor and transmit it, as you can see by the indicator LED on the board. This is a quick demo of the PCB transmitting the state information to the MongoDB database. As you can see, I have my Google Sheet here with the current unoccupied state for the parking spot. When the PCB detects motion at the parking spot, it'll trigger the Google Sheet to update and change the status to occupied. With another round of motion, it'll trigger it again and set it to unoccupied. We can see these changes reflected in the MongoDB database here.
Microcontroller demo. For the microcontroller demo, we will test 4 different QR codes, each with the same data. Each QR code has a different level of error correction and detection. L types correct up to 7%, M types correct up to 15%, Q types correct up to 25%, and H type correct up to 30%. The data consists of a two-part string separated by a comma, a garage name and a floor number. For example, garage D, floor 3. The string is stored in a data variable, which together with another variable with the user's information will be sent to the database from the microcontroller.
The following is a demo of our microcontroller, a Raspberry Pi 3B, a 5 megapixel camera module for ArduCam, which has a day and night switching mode, which allows us to read the codes even on a dark environment. And the last component is a 7-inch touchscreen, which will allow the user to use the application from the Pi without having to use a keyboard and mouse. For this demo, however, we will use a larger screen that will allow the scanning process to be more easily visualized. A power supply of 5 volts and 2.5 amperes is required to power the microcontroller, the camera module, and the LED touchscreen. The code in the microcontroller was done in Python, and it allows the camera module to read and decode the information on a custom generated QR code that has one string of data separated by a comma. We'll first scan an L level QR code. With no smudges and no errors showing on the code. This is showing on the Python shell the data found, and the detection is almost immediate of the data that was found. We will now scan an H level, the highest level of error detections, with no error shown. No, maybe I'll try por favor. We will now try our last 2 QR codes with levels Q and H. We also made a bigger smudge of hot sauce. So we will see if it's able to read it and detect the data. This is the Q level, and it's able to detect the data very fast, even though the smudge is covering pretty much the entire code. So now the H level, if we were to make the smudge even bigger, we will see if it's able to do it. As shown in the video, it is able to detect it, even though the entire QR code is pretty much covered in barbecue sauce. Thank you.
As seen in the demo, even the biggest smudge mark was not enough to deter the highest level, the H type, to detect the data from the QR code, and this was done in the matter of seconds.
For this part of the demo, we will be looking at the functionality of the mobile app, specifically the database to start off with. As you can see, we have a few users already loaded in here with all of their passwords hashed and encoded, and also a salt as well for extra protection. Let's go in and try and create an account that is already saved in the database. So let's do this valid at Gmail here at the bottom. Doesn't matter what we put in this name field. And if you register, it says email already exists. So whenever you can't have multiple emails in the database, which is good. Let's try and add a new one. Just do valid at one. Same password, and then we'll do Joe Tester instead and try and register it. And it says registration success. And if we try and load back up this users, we can see that Joe Tester is now saved in the database. Let's go and try and log in with that Joe Tester. Once we log in, you can see it says login success is a little toast, and it says welcome Joe Tester, pulls the name in from the database. The next step will be showing the available spots saved into the database. So right now we'll click on Garage A, and you can see it says 20%. And if we look in the car locations, you can see that for Garage A, all of these are Garage A. It says occupy true, true, and the rest of there's only 10, so the rest of the 8 are false. So this is pulling correct data. And also we can look into the output log, and you can see that it is is querying all of these and finding out how many of the spots are available.